Okay, so we're going to have quite a lot of quizzes, and you can already see a couple of them. I haven't put a full schedule up yet, but it's already made up, but I don't want to overwhelm you with too much information either. So I'm going to put it up as we go. But so our first quiz, quiz A, a little disclaimer, the numbering of the quizzes and also of these files and so might sometimes be a little bit odd, but that is because I'm using material from last semester where we only went halfway through an online system, and so my numbering got a little bit askew. So ignore these numberings. Also, if by accident any of these movies contain a date, ignore the date. There should be no dates here involved. When I say the next quiz is on this day, ignore that. Everything, the dates of the quizzes are as listed on the syllabus, on the website, okay. So this is basic integration, and I'm going to do a couple of examples. We have already, another, of course, preparation is the homework solution videos that I showed you, because it's exactly the same kind of questions. So here, let's start with a couple of these things. 6 cosine 3x plus 2dx. Okay, what's the antiderivative of this? This is an indefinite, so always be careful, is it a definite or an indefinite integral, right? So I'll do a bit of both. So what is this? Well, first of all, the 6 can come out, and then I have to take derivative of cosine, that is sine, but it is not just x, it's 3x plus 2. Okay, but then we know that if it's not just x, but it's a little bit more, we have to think. We have to say, is there anything that if I take the derivative of this thing is correct? Well, first of all, one thing is not correct, right? Because the derivative of sine, no, that's correct. The derivative of sine is cosine. So the plus and minus signs are correct here. But if I take the derivative of sine 3x plus 2, I'm not talking about the 6. The 6 is out, right? It's just a constant. What do I have? By the chain rule, I would get cosine 3x plus 2, cosine of the inside function, times the derivative of the inside function. What's the derivative of the inside function? 3, not 2, not 5, whatever you might think. It's 3, right? We don't want that 3, so we divide out that 3. So I'll write it here a bit separately. Where does this 3 come from? If I take the derivative of sine 3x plus 2, then by the chain rule, this is cosine, plug in the inside function, and then multiply with the derivative of the inside function. That's 3. And that's why I divide by this 3. Okay? Now be very careful, this can only work, I won't ask you anything else because it won't work otherwise, with things that are linear like that. If there would be an x squared, doesn't work. Okay? So this is the correct way. Sometimes people start integrating the inside function. No, this is how you have to do it. Okay? Plus c, of course. Okay, another example. Let's look at, I do a definite integral now from 1 to 9, x squared x dx. I always put in a little pitfall. What is the pitfall here? Is to think, oh, I have 2 powers of x, I'm gonna just both antiderive them. No, there's no product rule. You have to combine these powers as one single power. So let's do this. What power is this? X. What is radical x? So here I put this on the side, these are my explanations, right? It's x to the half. So now if x times x to the half, that one means we add exponents, so the whole thing is equal to this, right? So I explained this is x to the power half, x is really x to the power 1, and then multiplying two exponents is just adding them, so 1 plus a half. That is why my 3 halves comes from. Okay, so let me get rid of this and then go back to my calculation. That's the power rule for antiderivatives, means you add one to the exponent and then divide by that exponent. Now it's a definite integral, so I put 1 and 9 here. And then when this is definite integral, you definitely have to plug in the numbers. 9 to the power 5 halves minus, divided by 5 halves, minus 1 to the power 5 halves divided by 5 halves. Okay, now I'm going to show you that you can actually simplify this, because sometimes you're going to need to do this. No, if you don't need to do it, you don't have to do it. But I want to show you how it works. Well, first of all, what is 9 to the power 5 halves? There are two. It's a rational power. The numerator means the power, so this would be 9 to the power 5, and then the denominator of the exponent means a radical, the root 2 here, okay? So that's what this number means. Now dividing by 5/2 means actually multiplying with 2/5, okay? What is the same here, 2/5? What's the, any power of 1 is 1, so there I have I don't have to think anymore, okay? I can even calculate this number. 9 to the power 5. Oh, you get your calculator and start doing. No, don't use calculator. Use your brain here. Because there is another way of writing this, and that's why I want to explain this, because, as I said, sometimes we'll need this. You can actually, you think this is the only way you can write radical 9 to the power 5. No, you can also write it radical 9 to the power 5. Whether you first take up the power, then the radical, or the other way around, doesn't matter. That's the beauty of these powers. That now makes it much easier, right? Because what's 2/5? The radical of 9 is 3, so it gets 3 to the power 5 minus 2/5. And even 3 to the power 5, okay, 3 to the power 4 is 81, so this is 243. So this 2/5, 240 times 243 minus 2/5. But here I'm going to already, okay, you could go even a little bit further, but I'm no longer interested. Okay, but as I said, this is what I need to see. Okay, let's do another example. I'll do an indefinite again. X cubed plus 2x squared plus 1 divided by x cubed dx. Again, do not let yourself be fooled here. Don't take the antiderivative of top and bottom. Because, why? Because that's not, there's no rule like that. There's no quotient rule. So what you have to do is expand the quotient, so to speak. This means divide every single term by x cubed. Now, very often I see people do this. Oh, x cubed cancels with x cubed and that's it. No, that's not how it works. If you cancel within in sum, you have to cancel if you simplify within the sum, you have to simplify in every single term. In other words, you have to divide in every single term. So what you get is x cubed divided by x cubed is 1, that's true. But then also this one, what is that? That is 2 over x, right? And then the last one is 1 over x cubed dx. Now we know that we cannot antiderive powers in the denominator. We have to write them as exponents. Except that this 1 over x is a bit of an exception, right? So I'm actually going to leave that. But this one I want to write in the negative exponent. You could have done it right away. Okay, what's the antiderivative? The antiderivative of 1, I hope you realize that is just x, right? Just think of it, the derivative of x is 1. The antiderivative of the next term, well, that's the special one, that is 2 ln x. The 2, of course, is just a constant. Why? The antiderivative of 1 over x dx is ln x. You might say, oh, but it is this, and by the power rule is I add 1 to the exponent and then divide by this exponent, but this is clearly nonsense, right? You cannot divide by 0. Sorry, I shouldn't have scrapped out the whole thing. Let me just do this one. Okay, the top one is correct. And then the last one, that is, there it's just a power rule. Another mistake, people think, oh, now everything, if like this here, they say, oh, it's in the denominator, so it's ln of x cubed. No, the only time that you have an ln, if it's the power 1 in the denominator. So the antideriving this, you cannot think of it as an ln. It is really x to the power negative 3, and then you add 1 to the exponent and divide by it, and then plus 3. And that's it. Okay? Do one more. That was the last one. 3x squared plus 1 to the power x to the 5th plus 4 plus 7 to the power x to the 5th dx. Looks bad, but it is really not. The only thing that we need to do is one preparation step is write everything as powers of x, except for the 1 over x. You can also write it like that, but it's easier to remember that. And that is, so x to the 5th is x to the negative 5. There we have to write it with negative exponent. 4, this doesn't seem to be the any exponent, but it's actually x to the power 0 if you think about it. But okay, that's not important. And what is this one? Okay, this is just a little practice in rational exponents. First of all, positive or negative? Negative, right? Because in the denominator. Now, what is this? Yeah, by the way, if I do this video, I'm saying it a little bit late, I should have said it earlier. Do not just listen. You see my question, try it before you look at the answer, okay? So, I'm sorry, I say it is a little bit late. I appeal to your common sense to do this in the future as well. Okay, here. So, what is this now? Well, there's a denominator and a numerator. What is what? Well, the powers is always the numerator. This is the denominator, the index of the radical. It's a little bit confusing because the 3 looks like to be on top of the 5. Sometimes to not get this, I like to write it this way, like a big 5 and a 3 like very low, but it's still a little bit. You just have to remember how it goes. Okay, and now we can add the drive. 3, this is the constant 3, and then we had add 1 to the exponent, divide by it. Add 1 to minus 5, that is minus 4, divide by it. Sorry, I said constant in power. This is just 4x, don't forget that it's a constant, and the derivative of a constant is 4x, right? If you take the derivative of 4x, you get 4. And then the last one, add 1 to the exponent, so minus 5/3 plus 3/3 is minus 2/3 plus c. Now sometimes people get confused that they actually have already done an integral and start doing even more, one more time. No, only once, right? We're only integrating once, that's it. And there's nothing else you need to do here. I don't need to simplify, of course. I mean, it hurts almost to not do this, right? But you don't have to. Okay, I think that's kind of all the type of problems that I have now in this video, together with the one that I discussed in the homework video, should prepare you for quiz A. All right? Okay.